In this module, we shall look into a type of vulnerability called as cross-site scripting or XSS. Cross-site scripting or XSS is defined as a computer security vulnerability found in web applications. XSS allows for code injection by malicious web users into internet pages viewed by other users. In an XSS attack, the attacker gains the ability to see private user IDs, passwords, credit card information, and other personal identification. Cookie stealing and session overriding are the other effects of cross-site scripting. A general idea earlier used to be that injecting scripts into the search parameter of a search engine would be the fastest way to find out whether the web application is vulnerable to cross-site scripting or not. But with no such avenue now, the focus is on in-depth URLs in the web application where multiple parameters are passed. If any one of the parameters is susceptible to code injection, injecting a script would lead to its execution and thus prove that XSS is applicable on the application. Now there are so many aspects and parameters of a web application which are passed during normal mode of operation that it is hard to keep track of each of them. Apart from that, hiding malicious JavaScript in iframes present in the web application would enable a lot of data compromise. Cross-site scripting stems from the notion that a malicious website has the ability to load another website into another frame or window. This is accomplished by JavaScript, which is used to read or write data on the other website. There are several types of cross-site scripting vulnerabilities based on the type of injection and platform and can be classified as non-persistent, persistent, and DOM-based. All these subtypes shall be glanced upon in the subsequent slides. Non-persistent cross-site scripting is a temporary form of injection vulnerability. These holes show up when data provided by a web client is used immediately by server-side scripts to generate a page of results for that user. When non-validated user supplied data has been included in the resulting page without HTML encoding, this will allow client-side code to be injected into the dynamic page. An example could be when an attacker convinces a user to follow a malicious URL that injects code into the results page, thus giving the attacker full access to that page's content. This type of attack could also lead to unverified redirects to phishing pages, leading to identity theft. The persistent or type 2 XSS vulnerability allows most powerful kinds of attacks. This form of vulnerability exists when data provided to a web application by a user is first stored on the server, that is database, file system, or any other location. Eventually, this will be displayed to users in a web page without being encoded using HTML entities. This could lead to cookie stealing and session overriding, or even allow access to the client operating system. Rumor has it that if persistent XSS vulnerability is found in the web application, a well-directed script code could lead to information about the internal network that the server is connected to. This level of pervasiveness is indeed something that should be accounted when performing proper audits. Before we go into DOM-based injection, let us just get an overview of what DOM is. DOM, or Document Object Model, is a programming interface that provides a way for the values and structure of an XML document to be accessed and manipulated. Tasks that can be performed with DOM are navigate an XML document structure, which is a tree stored in memory, report the information found at the nodes of the XML tree, and add, delete, or modify elements in the XML document. In this form of injection, piece of JavaScript accesses a URL request parameter and uses this information to write some HTML to its own page. This information is not encoded using HTML entities. An XSS hole will likely be present. This written data will be reinterpreted by browsers such as HTML and could include additional client-side script. Apart from cross-site scripting, there are several other vulnerabilities which are closely related, such as cross-zone scripting, HTTP header inspection, HTTP response splitting, and cross-site request forgery. We shall now look into some of the ways in which cross-site scripting vulnerabilities can be avoided. Although Preventing such attacks takes a lot of dedication and research time during development and testing. Some of these processes could help streamline the problematic aspects of web applications. These methods include, but not end with, eliminating scripts, cookie security, input validation, and escaping and filtering. Going to the techniques of mitigating such threats one by one, we shall now see about eliminating scripts. In order to reduce the risk of identifying malicious script, hackers encode with the different encoding methods such as hex. Some web applications are written to function without the need for client-side scripts. In this way, potentially malicious client-side scripts could be inserted unescaped on a page and users would not be susceptible to XSS attacks. Attacking on cookies is another common method of breaching a web application's security perimeter, and so proper security measures during developmental stages of the web application would prove to be really effective in combating breaches by cross-site scripting. Many web applications rely on session cookies for authentication between individual HTTP requests. Because client-side scripts have access to cookies, XSS exploits are able to steal these cookies and hinder business functions. Web applications tie session cookies to the IP address of the user who originally logged in. Only that IP address is permitted to use the particular cookie. Attacking the web application vulnerabilities through morphed inputs from various input fields in the included web pages is a very common technique utilized by penetration testers nowadays. So, properly validating inputs presented by the client-side users is essential to web application security. Input validation is a common theme in application development. It helps decipher other injection attacks such as SQL injection through user inputs. It is effective for most types of input. Yet, when an application by design must be able to accept special HTML characters, HTML entity encoding is the desired choice. Another method of preventing such attacks from taking place is to take care of the parsing of input by the web application. One way to eliminate XSS vulnerability is to encode all user-supplied HTML special characters locally or at the server. Transforming these character entities will be essential in order to prevent them from being interpreted as HTML. Due to the flexibility and complexity of HTML, other standards and the continuous addition of new features, it is impossible to determine if all possible injections are terminated, but most of the injection attacks will be mitigated. The aforementioned techniques, although preventing scripting attacks to a significant extent, do not constitute the holy grail of security by any means. User awareness is also very essential to mitigate such attacks and the data loss that accompanies them. Listed here are some very basic measures that testers can follow in order to prevent such attacks from harming themselves. Do not follow links from sites that navigate to security sensitive pages referencing personal or business information at any cost. Also, it is good practice to obtain a list of attacks that have occurred on particular sites or message boards, which will help you to understand the types and patterns of scripting attacks in a realistic environment. In addition, it is recommended that users should disable scripting in browsers when it is not required. Keeping the rule of minimum trust in mind would be a good case in point here. By deferring from clicking on any suspicious links on emails and message boards and accessing any site involving sensitive information through its URL rather than through third-party sites. This was all for the module on cross-site scripting. I hope it was informative enough for you to grasp the essentials. Following this will be a practical demonstration for the same, in order for you to see what such attacks look like in practice.
Let's start with the demonstration of cross-site scripting. Now open the website. Now I'm using the website testphp.vulnerable.com. Now see how to test the cross-site scripting. I go to the tab which has a text box. Now I type a script, script script, and I close the tab with /script script. Now I want to display the alert message. I type alert, ALERT, and I display my message. My message is hello HELLO space Inobus. As I click it, it will show me a dialog box. Let's check. See, hello Inobus. I got my dialog box. It means my script is reflected. Means this application is vulnerable by cross-site scripting. Now check. Now I'm going to what I'm going to do. I upload some image in the website, and then I want to redirect it. I want to display that image on my vulnerable application. For that, I'm using postimage.org. This is a website. I open it, browse my image from a machine. I made an image named test for you. It's a JPG image. Now I upload it. So my image is uploaded. Let's check how it will show when somebody click it, or it will come in the portal. It will shows, hi, this file is for testing purpose only. Now I'm using this URL in the image source. I want that this image will be displayed in my vulnerable application. So I'm using HTML tag of image, and I replace that source with a URL where I have hosted this test for you image. Now I copy this control image tag and put it in the text box of the vulnerable application. Now see, this image is displayed in the portal. It means this application is vulnerable with cross-site scripting. So this is the demonstration of cross-site scripting.